Then we'll continue this seminar, and we are continuing on the same topic as before, and that is human exposure. And we welcome Jennifer Nystro from the Swedish University of Agricultural Sciences. And Jennifer will have us talk with the title Background Levels of PFAS in Drinking Water, a significant source of exposure for Swedish adolescents. So please, Jennifer, the floor is yours.
Thank you. Let me see here now. Can you see my screen? Great. Hi, everyone. My name is Jennifer Nystro. I'm a PhD student at SLU, specifically working with PFAS. And I will present today a report that me and my colleagues has been working on as a part of the Health-Related Environmental Monitoring Program, or HAMI in Swedish for short. Just a quick recap of the spread of PFAS to humans outside of occupational settings. As you know, PFAS has been detected in many different types of consumer products, in anything from upholstery, textiles, cutlery, cookware, fast food packaging, many different types of products. And this has and does play a role as a direct exposure to humans, although a very little exposure source. However, due to the global phase-out of legacy PFAS, predominantly PFAS and PFOA, the relative importance of this specific exposure source has decreased over time. However, once PFAS enters the environment, which it does through directly from the industry or the use of firefighting foams or insufficient waste management, the effect of these phase-outs takes way longer time to detect, making food one of the most important exposure sources to human, and predominantly then fish consumption, as well as also drinking water consumption. Highly contaminated drinking water is a known exposure source of PFAS, where the effect of this exposure source is still seen in human sera several years after the source has been removed from the humans. And the contamination of drinking water in Uppsala and Ronneby are a very classic example of the situation, but it's also been seen on a global scale as well. And in reaction to the discovery of these really alarmingly high concentrations of PFAS in drinking water in Uppsala and Ronneby in 2012 and 2013, the Swedish Food Agency established an action limit in drinking water of 90 nanograms per liter for some 11 of commonly detected PFASs. Although we know a lot that highly contaminated drinking water is a very important exposure source, very little information is known on the effect of low-grade contaminated drinking water. And when we talk about low-grade contamination, we're talking about contaminations that are less than 10 nanograms per liter of individual PFAS concentrations. So consequently, we wanted to evaluate whether there exists an association between low-grade contaminated drinking water and serum PFAS levels in Swedish adolescents. And for this, we use a subpopulation of the National Dietary Survey Riksmat and Adolescents, which was conducted by the Swedish Food Agency in 2016 and 2017. And this study population includes participants from 5th and 8th grade, as well as second year upper secondary school, which is andra år på gymnasiet. And what is really great with a specific population is that not only do we have a representative population that we can study, they also left, a portion of these also left blood as well as urine samples, and they also have collected conclusive information on demographics, lifestyle factors, as well as very detailed information on food consumption and dietary patterns. And to assess the effect of drinking water, we also asked the water treatment plants who deliver drinking water to the recruited schools in Riksmat and Adolescents to sample their drinking water twice to then be analyzed for PFAS, twice in 2018, once in spring and once in autumn, to account for potential seasonal variances. And the association was analyzed using classical general linear models. And to account for potential confounders that could potentially influence incorrectly any association we would find between drinking water and serum levels, we accounted for fish consumption, education level of the parents, participants' birth country, age, and so on, which are all known factors to have an influence on the intake of PFAS as well as the body burden in the participant. I think all in all, for this specific project, 1,097 participants had their serum analyzed for PFAS. But as we wanted to make sure that the association we were looking at between drinking water and serum was the possible strongest association that we could find, we only included participants who received drinking water from the same that delivered drinking water to the school, as well as the dress. So all in all, we included roughly 800 also had participants from Uppsala and Ronneby, but to make sure that the high concentration in some of these participants that we did find would not influence the association, we made sure to do a sensitivity analysis, basically excluding these participants. Yes, so in front of you now is the table on the drinking water concentrations for the 44 water treatment plants that were that had detectable concentrations in spring as well as in autumn. And we see the ranges that were detected in both spring and autumn, as well as how often in how many water treatment plants each PFAS was detected. We can see, which is very positive, that none of the PFASs had some 11 PFAS levels exceeding the Swedish Food Agency's action limit, and neither did we see, because we analyzed other PFASs as well, that neither of these exceeded the action limit if we added all of them together. What we can see here that is slightly wider range of the concentrations in spring. However, this is not the case in autumn. And PFBA is maybe one of the big drivers for the maximum for the sum maximum that we see here. But what is interesting also here is that we see FOSA, which was the second most frequently detected PFAS, and FOSA is, if I'm not mistaken, not included in the 11 PFAS action limit, which maybe could be something to potentially include in the future. Now, looking at the levels of PFAS in blood, only PFOA, PFNA, hexensulfonate, and PSOS had detectable concentrations in more than 70% of the participants, and were then consequently included in the regression analysis. We can see here that a few of the participants had really, really high concentrations of specifically hexensulfonate and PFOS, and you might have guessed that these are in fact participants who were residing in Uppsala and Ronneby. Quite fittingly, these are also the 4 PFASs that are included in EFSA's latest scientific opinion that Emma told us about earlier today. So just to compare, it might be interesting. The girls' medium serum levels, we can, or the girls' serum levels with the mother's TWI that corresponds to a benchmark dose of roughly 7 nanograms per milliliter serum, or 6.9, I think it was exactly. We can see that 134 of these girls had concentrations exceeding the sum of these 4 PFASs, or roughly, I think, 22%. And this is quite disconcerting, especially considering that a few of these girls are entering the reproductive stages of their life. Now, circling back to the association with drinking water, here we can see the adjusted geometric mean PFAS concentrations, which has been stratified by level of contamination in drinking water. The reference value is the lowest one here, and in here we find participants who have been receiving drinking water with non-detectable concentrations. And the 2 other categories are basically detectable concentrations that have been, that we took the median. So here we have participants who receive drinking waters which are higher than detectable median concentrations or lower. And what we can see basically is that if these participants have been drinking water with detectable concentrations, we would see a significant increase in serum levels. when the highest difference in concentration is for hexane sulfonate, down here, where we see, I think it's roughly 70 or 80% increase in serum level compared to participants who've been receiving non-detectable concentrations. There we go. Now for the sensitivity analysis, like I said, where we excluded participants who have been receiving, who have been living in Uppsala and Ronneby, which are the dashed lines, but also I kept the other ones just for comparison. We can see that for PFOA, PFNA, and PFOS, only the highest category, that is participants who've been receiving drinking water concentrations above the median detectable concentrations, that is, had significantly higher concentrations compared to the reference group. And this is, however, not the case for hexane sulfonate again, but the main exposure source for this specific PFAS is drinking water, unlike the other PFASs. But it's also important, even though we're talking about, even though we're seeing only in the highest category, we're still talking at really, really, really low concentrations, or yeah, that was maybe not scientifically so scientific, but we're seeing really low concentrations. Hello? Low concentrations, where we see, sorry, I'm not sure if I cut out or not. My laptop stopped, so I will just refer to what I said again.
Yeah. I think maybe your.
Can you hear me now?
Yes, but it's a little bit difficult sometimes. I think it's your connection maybe to your own internet. I don't think we can do anything from our side now.
Okay. Do you think I should go on?
We hear most of it.
It's not a big problem.
No, it's not a big problem. Just go on.
Okay, you hear most of it. Great. Okay, great. Sorry about the connection. It has not been an issue so far. Of course, it starts now. But what I meant to say here is that the concentrations in the highest category is still quite low. For PFOA is 0.5 nanograms per liter, for PFNA is 0.16, hexane sulfonate 0.45, and PFOS 1.80. So we're talking quite low concentrations where we do see an effect. And one of the probable reasons that we do see this effect is probably because of a diffuse exposure in general from other sources, making a very small continuous source like this to stand out. As a little side note, we also analyzed the participants' serum levels for additional extra target analytes that were then not analyzed in the drinking water. And we could see that participants who had been residing in Uppsala and Ronneby had significantly higher pentane sulfonate, heptane sulfonate serum concentrations. These levels are of semi-quantitative quality due to the lack of internal standards. However, it's likely that these two compounds were also in the technical mixture of the firefighting foams or other point sources that contributed to these very high concentrations, which just highlights the need for more research on other PFASs besides these legacy PFASs, considerably so because these also have been known to have long half-lives. So in conclusion, no water treatment plant had concentrations exceeding the 90 nanogram action limit, which is great. We also saw that FOSA was one of the most frequently detected PFASs, so maybe in the future it could be included via in the Food Agency's action limit potentially. 20% of the girls had serum levels exceeding the benchmark dose that corresponds to the mother's TWI. And we also see that low-grade concentrations of PFAS in drinking water is an important exposure source for Swedish adolescents. And finally, maybe pentane sulfonate, heptane sulfonate should also be routinely analyzed in drinking water in the future. Thank you so much for your attention. I'm really sorry about the connection. This has not been an issue before, but I'm hoping you got what I wanted to say, and I'm looking forward to any questions that you might have.